Hi, in this video we're going to try and formalize the work that we've done on long division of polynomials into a bit of theory which we're going to call the remainder theorem. Now, I've gone through certain examples with you and they look something like this. The first example, we went and said this expression over here, x cubed plus 3x squared minus 2x plus 1, that was the same as saying x plus 1 multiplied by x squared plus 2x minus 4, and then there was a remainder of 5. This part over here was the remainder, the part that is left over. The second one that we did was 2x cubed plus 11x squared plus 10x minus 2. We divided that by 2x plus 3, and that gave us an expression that looked like this. X squared plus 4x minus 1, and then there was a remainder that was 1. And the last one that we took was x cubed plus 2x minus 5, and we went and divided that by x plus 2, and so we say we could write this as a product of x plus 2 times x squared minus 2x plus 6, and there was a remainder this time of 17. Now, in each of these situations, we've been able to write the original polynomial, this thing over here, as the product of two factors and a remainder. So, in other words, if I've got a polynomial, which I'm going to call f of x, I could write that polynomial as looking something like this: ax plus b. There's my little linear divisor that we've had before, and that's going to be multiplied by some other polynomial. I'm going to call it g of x at this stage, and then I've also got to take into consideration that there may be a remainder that's left over. Now, we can actually work out this remainder over here, this part here, without having to do a great big long division as we've done before. And we do that by saying, okay, well, if I want to work out if I want to find out what the remainder is when f of x is being divided by ax plus b, well, it'd be good to get rid of this part over here. And the only way in which we're going to get rid of this part over here is to go and say, make ax plus b equal 0. Because then I've got 0 times g of x, and that's just going to disappear. So if I've got that, I can then say, well, x is going to equal minus b over a. And so if I go and say, right, what is f of minus b over a? Well, I'm going to put that into my formula. I'm going to have a times by minus b over a plus b. There's my first bracket. I'm going to have g of minus b over a plus my remainder. Now, this first bracket over here, a times minus b over a, that's just going to leave me with minus b plus a b, and that's going to give me nothing, 0. I don't need to try and figure out what g of minus b over a is, because I'm going to have this situation over here of g being multiplied by nothing. And so I'm going to say, right, so f of minus b over a is equal to my remainder. Now, you don't need to learn this theory. I'm just explaining to you. But what you will need to learn is the formula, or the theory, the statement that goes with the remainder theorem, and it goes something like this. This is the formal statement of the remainder theorem. If a polynomial p of x is divided by a linear expression in the form ax minus b, then the remainder is given by p of b over a. Now that's a bit of theory that you will need to know, and you're going to use it quite a lot. So let's just see what this means in terms of the examples that we've done so far. In the first situation, we said that f of x was equal to this function here, x cubed plus 3x squared minus 2x plus 1. And we wanted to know what f of x was if I divided it by x plus 1. So what is the thing that will make this x plus 1 bracket equals 0? So if I do this over here in my head, x plus 1 equals 0, x is equal to minus 1. If I go and substitute minus 1 into f, I should get what my remainder is going to be. So f of minus 1 comes up as minus 1 cubed plus 3 times minus 1 squared minus 2 times minus 1 plus 1. So this is minus 1 plus 3 plus 2 plus 1, and that's going to give me an answer of 5. And 5, if we go back and take a look at it, was the remainder that we had. Let's take a look at the second one. The second one, g of x, was the expression that looked like this, 2x cubed plus 11x squared plus 10x minus 2. And we were going to take g of x, and we want to divide it by 2x plus 3 in order to find the remainder. Well, if 2x plus 3 equals 0, x has to equal minus 3 over 2. So if I go and find out what is the value of g of minus 3 over 2, I should come up with the remainder. So what am I going to have here? I'm going to have 2 times minus 3 over 2 cubed plus 11 times minus 3 over 2 squared plus 10 times minus 3 over 2 minus 2. And if we go and take a look at that, well, we're going to come up over here with minus 27 over 4 plus 99 over 4 minus 30 over 2 minus 3, minus 3 minus 2. And that's going to come up with a number of 1. And 1, look back and see there, 1 was the remainder that we got. So this is a very simple way of being able to find the remainder when you divide a polynomial by a linear expression. In another video, I'm going to show you how we apply this particular remainder theorem to the sorts of problems that you can expect to come up in the exam papers. So we'll deal with that in a later video. Cheerio.